So hi all, welcome back. And in this video, we'll be talking about polymorphism. So it says polymorphism is the ability of different classes, right, to be treated as instance of a same class through a common interface, right? So we'll see that with an example, right? So we'll quickly go to an example. So now if you see in this snippet, so there is an interface called as speakable, right? So it says there is a method called as speak. Now this is a concrete class called as dog, and this implements the interface that we defined earlier, that is the speakable interface. So now it has to override this method, and it says, it returns oof. And there is another class called as cat, and this also implements the same interface. And finally there is robot class which also implements the same interface, right? So now if you see here, in the main function we are creating speakable dog is equal to new dog, speakable cat is equal to new cat, speakable robot is equal to new robot. So how are we doing this? So how are we creating objects of different types, right? See, all of these, if we go back to the example, dog, cat, and robot, right? So we're creating objects of different types, right? But they are mapped to a common type called as speakable, right? So this is what the definition says. So the definition says polymorphism is the ability of different classes to be treated as instance of a same class. Isn't that what we're doing? So all these are different classes, right? Dog, cat, robot. But whenever you are creating an object or instance of a class, see, we are creating the type of this object is speakable, right? So that means even though they are of different classes, we can consider them as object of a same type. Why are we able to consider that? Because in this case, all of them are implementing the same interface. So this polymorphism can be, achieved by different ways. You can use interfaces for polymorphism, you can use inheritance for polymorphism. So this concept of polymorphism can be achieved by different ways, right? So that's what this definition says. It says, the ability of different classes to be treated as instance of a same class, right? So if you see, all of them are different classes, but whenever you are creating instance of a class, we are saying all of them are of the type speakable, right? So this is called as polymorphism. Now when you call make sound, you can pass any of this object that you have created, because you know what is make sound doing? It is calling speaker dot speak. Now speak is something that is for sure implemented on all these classes, right? Because all of these classes are implementing from this interface. So that is why we can use them interchangeably, right? This is the main concept of polymorphism, and we'll see what are the different ways we can achieve this. So in Python, there is a certain thing called as a duck typing. So what does Python say? So it says in duck typing, if it walks like a duck and if it quacks like a duck, then it's a duck. So we'll see this, what is this thing with an example. Okay. So let's understand what is duck typing. So we'll see the definition of it, right? So it says duck typing is pretty popular in Python. The language documentation defines duck typing as below. So it says this is a programming style which does not look at the object's type to determine if it has the right interface, right? So it will not take a look at the type of the object. So if you see here, earlier, these objects are there, right? These objects are of same type, right? Speakable, right? So this is very simple. I mean, it says don't look at the object's type to determine if it is a right interface. So you don't need to look at the object type, right? If you see, okay, now if you see this example, it says, okay, dog object is of type speakable. Okay, so then you'll know that, okay, speakable is interface, right, with the speak method. So you'll know that, okay, for sure, this class, whichever is implementing it, will have this method. But instead of that, so what they say is, instead of looking at the object type, take a look at the methods or attributes, right? So if it has all the methods and attributes, right, required, then we can use them. So here is a quick example that involves birds that can swim and fly. So you have a class duck, and they have two methods, swim and fly. And you have a class span, and it also has two methods, swim and fly. And finally another class, it also has two methods, swim and fly. So in this example, if you see, three birds can swim and fly. However, they are independent classes. If you see, if you create objects of these three classes, they are independent, right? Because this is a different class, this is a different class, this is a different class. But if you see at the method signature of all these classes, it's the same, right? So this first class also has swim and fly method, this span also has swim and fly method, and this albatross also has swim and fly method. So that means you can use them flexibly, right? So because they share the same interface, you can use them in a flexible manner, right? So now if you say birds is equal to duck, swan, and albatross, you can do something like for birds in birds, you can call birds dot fly, right? So because fly is something that is there on all these classes. So it says Python doesn't care about what object bird is holding at a given time, right? So it doesn't care what is the object bird is holding at a given time. So all it cares is whether it has the fly and swim method, right? So if all these classes have the methods defined, right? So that means it just calls the expected methods. So it says if the object provides the method, then the code works without the breaking. That's the flexibility that duck typing offers. So the duck typing system is pretty popular in Python. In most cases, you shouldn't worry about making sure that an object is of right type for using it in a certain piece of code. Instead, you can rely on objects that quack like ducks and walk like ducks. So it means, so what are they saying is, in most cases, you don't need to worry about making sure that object is of a right type, right? So you don't need to make sure that is this object which I am creating, is this of a same type as speakable interface which I defined. So you don't need to worry about that. So if an object has required methods, that's all, then it can be used regardless of its type. So no matter if it is a if it is a duck class or swan class or albatross class, if the object of that class has the required methods, then that's all, it can be used regardless of its type, right? So this is duck typing. And now in this example we saw uh, polymorphism using interface, right? So now we'll see polymorphism through inheritance. So what does this say? This says when classes inherit from common base class, they can be used interchangeably, right? Simple. So you have a common base class, and then whatever classes that inherit from the one base class, you can use them interchangeably, right? So like this, something like this. If you see, there is in this example, to the right side, shape is a common base class, right? So whatever subclasses that inherit or extend from this class, you can use them interchangeably. So that's what it says. So you have a vehicle class. Now you have another class called as car, which is extending the class vehicle that we defined earlier, right? So because it is extending, it has ability to override the behavior if it want, right? So in this case, we are overriding. So it says, brand and model, car started with a roar, etc. And same thing for motorcycle. It also extends vehicle, right? So what does it say? Brand and model, motorcycle started with a vroom, something like that. So electric vehicle, same, extends the same class, vehicle class, and then it also has its own, written statement. So now if you go to the main class, so you have a method called as start vehicle. So what does it do? It takes a vehicle, right, which is of a vehicle type, and then you are doing something like vehicle dot start and then vehicle dot get info, right? So now if you see, we created instance of a class car, right? Car is equal to new car, and then you created instance of a motorcycle, and then you created instance of a electric vehicle. Now, if you call start vehicle on car or motorcycle or electric vehicle, anything, it should work, right? Because ideally it is extending from a same parent class, right? That is the vehicle class. So that is what it says. When classes inherit from a common base class. So that means this car class and motorcycle class or this electric vehicle class, they are extending from a common vehicle class, right? So are extending from a common vehicle class. So in this case, when classes inherit from a common base class, they can be used interchangeably, right? That is how we are using. See, when you are calling start vehicle, now if you see start vehicle accepts, something which is of type vehicle class, right? So that means something which is of type this vehicle class. But even though we are sending a car or motorcycle, right? So if you see this example carefully, start vehicle accepts a vehicle which is of type vehicle class. But here if you see, we are sending car, motorcycle, electric, right? So even though we are sending these things, it is working, right? Why it is working? Because all of them are extending from this base class, right? This is how we can achieve polymorphism using inheritance. So let's see another example, payment processing. So this is your base class payment method, right? This is very classic example that we saw several times earlier too. So you'll have a base class called as payment method, and then you'll have different payment methods like credit card, PayPal, bank transfer, and all these things. Now all these child classes, they extend from this, parent class, right? So all this class, they extends from a parent class. Now what flexibility does it give? Same thing exactly, right? So if you see to the main method, so you have something, shopping cart, you added few items to a shopping cart. But if you see, you are creating an instance of a class credit card, you are creating instance of a class PayPal, you are creating an instance of a class bank transfer. But the type of these objects that are created, they are all type of payment method, right? So how are we able to do that? Because all these subclasses are inheriting from the same parent class, right? So we can use these classes interchangeably, right? Now what does this give us? So you can simply call card.checkout credit card. If you see this, what is this checkout method? It says I accept something which is of type payment method. Consider that you don't do polymorphism, right? So you don't have this concept. Now what essentially you'll have is, so you'll have one checkout method for credit card. So you'll be writing something like checkout credit card, right? Checkout PayPal, and then checkout bank transfer. So you'll be having three different versions of a same function, right? So that is something that is bad. So instead, what are we doing? So we are creating a parent class, right? That is the payment method, and whatever the generic, logic that has to be there, the generic methods, they'll go into this parent class. So this is an abstract class, so there will be no implementation, but it says, so whoever is extending the payment method, they have to have the process payment, right? So now if in the checkout method, you can simply use this payment method and pass either of these methods interchangeably, right? So you don't need to have separate methods saying that checkout credit card, checkout PayPal, checkout bank transfer, right? So this is the advantage of polymorphism. So now finally we'll see how we can achieve polymorphism with abstract classes. So this is also exact same thing. So we saw the concept of abstract classes earlier too, right? So this is just kind of a contract, right? So this is just an outline. So there will not be any implementation, right? So we said there will be a class, shape, and these two are abstract methods, right? So whoever is extending this base class, they have to implement it. Same thing goes in Python too, right? So you have a shape class, that is abstract class, and you have two abstract methods, area and perimeter. So there is a rectangle class which is, extending this shape class, and it for sure has to have area and perimeter. Same goes for circle too, it for sure has to have area and perimeter. Same for how many other classes that you have. Now finally, if you go to the main method, right here, you can see that. So you created instance of a class rectangle, instance of a class circle, instance of a class triangle, and then see this print shape info. What does it accept? It says I accept, object of type shape. right? But here we are passing object of type rectangle, object of type circle, object of type triangle. How are we able to pass this? Because we are implementing the same base class, right? So in this class, in this case, we are implementing the same abstract class or extending the same abstract class, right? So we can use them interchangeably. So this is what polymorphism with abstract classes mean. So we'll go to one final example. So this is a notification system. So as you know, there are different ways to send notifications, right? Email notification, SMS notification, etc. Right? So here you have an abstract class notification, and then you have an abstract method that send, right? So now email notification extends the same abstract class, so it has to override the send. Same thing for SMS notification, it has to override. Same thing for push notification, it also has to override the send method. And now in the notification service, if you see, there is a list of notifications, that is this abstract class that we defined earlier, right? So list of this type notification. Okay, so notification service means this dot notifications is equal to a new list, right? So this creates a new list, and then whenever you call add notification, it will take notification object of type notification, and then it adds to this list that we defined earlier, right? Now when you call broadcast, so for all the notifications that are present in this notification list, you will call the send. Okay, so now in the main class, if you see, we are creating new instance of a notification service, and then we are adding the email notification, SMS notification, and push notification. So as we saw earlier, this what does this add notification do? It will add these all these three to a list of type notifications, right? If you see this accept, object of type notification, we are able to pass different notification services. Why? Because all of them are extending from a abstract class which is of type notification. So because they are extending from this abstract class, they'll have this send method for sure implemented on all the child classes or all the classes which are extending from this abstract class. So we can use them interchangeably. So finally, what are the benefits of polymorphism? So code reusability, right? So we are writing code once and you are using with multiple types, right? So you are same thing we are using with multiple types. Flexibility, so easy to add new types without changing existing code. So if you want, tomorrow you want to add another notification service, right, like WhatsApp, you can easily add that service here. So you can easily add new types or delete existing types. Maintainability, right? So changes to one type does not affect others. So tomorrow if you are writing notification type for WhatsApp, etc., you don't need to do changes in other notification types, so they will not be affected. Finally, simplicity. So one interface for multiple implementations. So you have one interface, like this notification, and then this says what is that, one method that all the child classes have to implement, and then they'll define them, right? And then finally, easy to extend functionality. So this is all about polymorphism. This is something very important that we use, overall all the design patterns that we'll be seeing further. So it is nice to take an example of this, copy to your id of your choice, and then play with this example so that you'll understand the benefits of polymorphism, and how can we use these objects of different classes interchangeably, right? So that's all on polymorphism for this video. In the next video, we'll be talking about abstraction. So that's all for this video. Thank you. See you in the next video.